Okay, so we're on to section 1.2. We're looking at segments. Now, before we begin, just remember you've got the blank copy in front of you. So anything you see here on the video that you don't see on your paper, feel free to pause and copy down because you're going to want to have that key information. Most of the stuff that is not on your handout should actually be in a different color. So the blues and the reds, you want to make sure you actually get that down. Okay, so now let's go ahead and dive into segments. So remember from last class, we said segments are that piece of a line that has two distinct endpoints. So that makes it just that tiny piece of a line. And what's great about a segment now is that we can talk about what the measurement of it is, what the length of it is, right? How many inches it is, because now it starts and finishes somewhere. Whereas a line goes on and on forever, so we can't actually measure it. So the first thing we're going to talk about is this idea of congruence. So when two segments are congruent, first we have to think, well, what does that mean? Well, this word congruent simply means they are the same size and shape. And this is important because it's different from being equal. All right, so you might be wondering, wait, same size and shape, isn't that just equal? But when we talk about equality, we actually talk about number values. So we say 2 equals 2, or the variable a equals a, where a represents some number. So congruent talks about the idea of the figure, so the shape itself. We're not saying we're looking at the size, but we're saying if I take two segments and match them on top of each other, they overlap perfectly. So that's the idea of congruent. Very similar to equal, and most cases, if it's congruent, it's going to be equal, but the definition, that meaning is different. So you want to keep that in mind. When we talk about congruent, think image. When you think about equality, think number. So since congruence and equality are so similar, but they are different, we use a different sign for congruence. But we're going to go ahead and when we use the congruent idea, our base symbol is still the equal sign. So we're going to go ahead and draw an equal sign, but instead of leaving it as equals, we put this curved tilde on top, and now we've created congruence. Okay. So now let's talk about congruence in terms of this first diagram. So when you're looking at segment AB in red and CD here in blue, you might think, oh, well, look at them. They look congruent. They're matching up. Looks like it's about the same. You want to catch yourself when you do that. If you heard that keyword I said, it looks the same. It looks like it matches. We're mathematicians here, and we don't want to go with just, well, it looks right. We want actual proof, right? Things that cannot be contradicted. When we say, okay, they're equal, and someone says, how do you know? We can prove it by using actual facts. So looking at these two segments, AB and CD, we can't say they're actually congruent or equal right now. But if, for example, we knew their lengths, their measurements, remember we can measure them now because we have endpoints. So for example, if I had told you that AB is 2 centimeters and CD is 2 centimeters, what do we just see here? Well, we know that since 2 equals 2, AB is equal to CD. And you'll notice how those lines on top are missing. All right. So whenever we're dealing with measurements or numbers, we don't need the segment on top. Okay? And because they're equal, we can say, well, if they're equal, then they must be congruent. So that equality and congruence are connected in that way. So when we're using congruent, then we're going to go ahead and use that segment notation with that segment line on top. Okay? So those are for numbers here, the measurement, where we don't have the line, and this is for the picture and the idea of it. So that's congruence. Something else you want to know, if you don't know the measurement, for example, this 2 centimeters and 2 centimeters, another way to show congruence in a diagram is using a tick mark. And what I mean by a tick mark is one of these little hashes. So if you see here, AB and CD have the same number of tick marks, they are congruent, right? So 1 and 1. However, if I put 2 on AB like this and leave 1 on CD, that means they're not the same. But again, if they have the same number of marks, so if I add 1 more onto CD, now they're congruent again. So be aware of the notation. Okay, so that's congruent segments there. Let's take a look at this example. So remember again, segments we can read from any line. We can take any points and they can become segments. So if we're taking a look at part A here, we want to find AB and BC. Remember, make sure you know what the problem is asking you to do. So whenever we see this right here, AB and BC with no lines on top of it, this means we want numbers. We want the measurement. Okay, so that's the first part. And then we want to ask ourselves, are they congruent? So the first thing you want to do here is tell me, well, what's the length of AB? And here it's a number line. What do you think you're going to do? Just count, right? So A is at -8, B is at -5. I'm moving over 1, 2, 3. So AB is 3 units. Okay, we're going to do the same thing for BC. Let's make that a little clearer. BC, same deal. B starts at -5. C is at -2. So that means we're moving over 1, 2, 3 units to go from B to C, right? 1, 2, 3. So that means BC is also 3 units. And you can use UN to abbreviate units here. You do want to make sure you do units when they're appropriate, something you're going to need to do when we start looking at area and volume. So just a good thing to keep in mind. So something else to think about here is the logic behind the problem. So we know AB is now equal to BC because 3 is equal to 3. So those measures are equal. And remember, we said equality is tied to congruence. So if they're equal, then they must be congruent. Pretty awesome, right? Okay. Then if we take a look at this segment AC, remember, it's perfectly fine to skip over other points. You can have one start and one end point on any part of the line. So we can do the same thing before. And remember, this notation AC without the line on top means we just want that number value. Okay, so I can start at A and I can count to C, or something you might have noticed, there are 2 segments that actually make up AC, and we just looked at them earlier. AB and BC. So I can just add 3 plus 3 to get 6. So that's something to keep in mind as we go through this first part with segments. Oops. Let's say AC is equal to 6 units. All right. Okay. So C, find 2 more pairs of congruent segments, write the equality statement and the congruent statement. Go ahead and try that. There's a few different ways you can pull out a couple of congruent segments. We can talk about this in class.